Well, hello all. Thank you for tuning in to We'll Fix It Team. Today is a history lesson in the wide world of carburetors. And something that is not talked about, I don't see a lot of articles on the internet anymore, it's sort of obscure and lost, is the old shoebox Autolite 4100. And what I have here is a particular model that dates back to 1965. And I'm going to give you a little bit of a rundown of about this thing. Let's flip the camera around and I'm going to show you a few things that I like about this carburetor and why we're going to use this. We're going to build this thing and put it on a vehicle, but now we're just doing a little history thing. So let me flip this camera and I'll show you real quick. Okay, so what we've got here is the old quote-unquote shoebox Autolite 4100. They use this carburetor all the way up until 69. I'm gonna go through a little bit of we're gonna read a little bit too, so I can show you. I've got an article that kind of goes into the history of this, but just for the purpose of the video, I want to show you something. You'll see that the first two letters, or the first two digits here, whatever you want to call it, it says C5. That right there is a very, very good thing to have this tag on this carburetor. Assuming it's the tag that came on this carburetor, gives us a great specific year. I'm going to give you a little history on that. The letter B started in 1950, and then the number that comes after that, whatever that would be, a 3, 4, or 5, would give you the year in that decade. So B would be 50, C would be 60, D would be 70, E would be 80s, F would be 90s, and so forth. And they use that letter code almost to this day. I think it probably changed a little bit. I don't know what year they started getting away from that, but so we see a C5. So this dates this carburetor back to 1965. It's a square bore carburetor. I found it in an old building somewhere, so we've got to do a little work to get on it, but there's the rear venturis are a little bit seized up, but I think I can free those up. Now, similarities of the 2100, which would be the two-barrel version of this, is the power valve down here at the bottom, and it's similar to what a Holley would use. As a matter of fact, I think they're kind of interchangeable for like the Holley 2150s and so forth. It's got an accelerator pump at the front of the venturis, or the front bowl. There's your accelerator pump. And I'm going to tell you about the back here in a second. That's not an accelerator pump. Just to let you know, that is a part of the vacuum secondaries. It uses to open the secondaries up. It's not a mechanical secondary. It's actually a vacuum. There's no linkage hooking the secondary throttle venturis to anything other than the vacuum signal that would come from a port. A lot of times it'll come from the center right here, and they'll port that through. Now, the fun thing about these carburetors is they're super, super reliable. Very simple. You could actually take the top off of this carburetor and crank up your vehicle, and as long as your float level's correct, it will sit there and run just fine, and you can actually see it work in real time. The float will go up and down, and you can see the entering for your fuel. It's a single line feed. It uses a transfer tube inside of the bowl of the carburetor right here that allows fuel to go to the rear of the carburetor, the rear bowls. And being as a vacuum secondary, that's actually relatively handy, especially on stock applications where you have a highway gear, a heavyweight vehicle, and it gives you an excellent throttle response at full throttle versus something that's mechanical secondaries that typically would maybe fall on its face due to the loss of vacuum on intake. Now, what I like about this carburetor as well is the fact that it's similar to the 2100, so it's kind of easy to get parts for the most part, except for this little vacuum secondary diaphragm, but most of the time they hold up pretty good. We'll put that. I've got a new kit, new old stock, and these were used, I think, to begin with on the like 312 Thunderbirds, like the Y blocks, which would be 292 truck motor, 312 Thunderbird Lincoln, and I think a Y block got all the way up to 332. We'll have to dive into that history a little bit. But it's a square bore, which is nice too. I like the square bore design. Far as like, well, I like a spread bore too for certain reasons. I'm not a hater of the old Quadrajet carburetors. When they're working right, they work really well. So you got an accelerator pump here, a vacuum secondary lever actuated by a vacuum that opens the rear butterflies, venturis, and you have annular boosters just like the front does. In other words, it uses a power valve to kind of actuate fuel to that. And, of course, you have an automatic choke that is heated by exhaust that comes from the exhaust manifold. And so what we'll do now is we're going to dive into just a little bit of history. And let's do that real quick. All right, guys, don't mind me in the bottom corner over here. We're just hanging out. This is a Hemmings.com excerpt article written, and it helps us kind of decipher what we're working with and what years they did this. So the Autolite 4-barrel carburetors right here, there's a couple of pictures. They go, I'll give you a little bit of the read-ins to it. It says, we have spoken quite a few about carburetors in the previous instance. Originally, the installed on the 312 cubic inch V8 in 1957, the first generation Autolite model was referred to as the 4100. Using of its bare-bones square-bore 4-barrel continued on numerous 8-cylinder configurations until finally phased out in 1969, on which I believe that would be the first year of the 429. That was the deck they used to build the 460 a little bit later on. People get the 460s and 429s confused with the 351M 400 motors, which were their own engines all to themselves. Quite a weird design because of the deck height. And they did that because they were trying to fight the emissions and compression ratio and getting the best out of the torque. So like a 400 was a D-stroked, I'm sorry, a 351 was a D-stroked 400, and they called that the 351M. And what I believe that did was change the bore and stroke ratio out and give you a little bit more of an eccentric on the crank to give you that extra torque. A lot of those were truck engines, ironically, and then the Lincolns and the Thunderbirds would get the 400Ms at the time. So anyways, back to this here. So the 4100 is a very low maintenance carburetor. Once it has been set up properly, the one-piece cast design of the fuel bowl means the chances of a leak in the center section of the carburetor are nil, which they are. The way that they vent the carburetor works really well too. Yeah, like I said earlier, experienced mechanics will tell you can remove the top section of the carburetor and adjust the floats while the car is running. You could. Debuting in 66 was the second version. So what we're looking at there, if that's correct, that's a first generation 65 model. The 4300 incorporating some design improvements. Ford and Mercury used the 4300 models up to 1974. Some 74 pickups with 460 engines. Also used the 4300, which discontinued in the Autolite 4 barrels in the Ford Mercury passenger cars in 1974. Lincolns and trucks with 460s continued to use the third generation Autolite 4 barrel, which was a 4350 until 1978. Now, I have to do my research, but I believe that's a spread bore model, and I have one of those. And the American Motors 8-cylinder engine also used, which would be the AMC model, would use this Autolite carburetor 4-barrel models, employing the 4300 model in V8 cars from 70 to 74. The 4300 models from 1975 to 1976. The Jeep also continued to use the 4350 until 1978. Here's a list of stuff here that you can go by. So the 57 Ford Mercury and Thunderbird with the 312 cubic inch engine, 58 to 60 Ford and Edsel, 332, 352, 361s, which were early FE blocks. The 1961 to 65 Ford 390, including the Police Interceptor. This 1962 Mercury 406 engine. Remember, Ford made they had a 410 that they used, which was an awesome engine. It was only a one-year engine, I think, but that was a really cool design. Ford and Mercury used, by the way, if you had a 427, you were somebody back in the day. 1963 to 1965 Fairlane, the 64-65 Comet, the 65 Mustang, and a 289 cubic inch. The Mercury 65 to 66 410 and 428 engines. And then 57 to 65 Ford heavy-duty trucks, 272, 292, 330, and 352. Those were all Y blocks. And then you had the Thunderbird with the 428, 429 cubic inch engines. Autolite 4300 carburetors came with on these vehicles. 1966 to 1974 Ford, Lincoln, and Mercury cars with the 302. The old 302 was a side load engine. You know, in other words, if you revved it up real high, you could actually break skirts on the 302s because of the bore and stroke ratio. If you look at the crankshaft eccentric, you could actually see how much it would actually push sideways on the piston. So high RPMs were sort of a good thing for a 302, but also a give and a take. The 289 benefited the most of that short stroke because the bore was different, so it wouldn't side load as bad. But anyhow, 351 Windsors and the 410, 429, and 460 engines. 1970 to 74 AMC Jeep with a 360, 390, and 401 cubic inch engines. The 70 through 74 Mustang 351 Cleveland and a Boss 351 used the Model 4300D spread bore. The Autolite 4350 carburetors were also available on these cars and trucks. 75 to 78 Lincoln 460, 73 to 78 Ford pickups with 460s, 75 to 78 AMC Jeep with the 360, 390, and 401 engines. Autolite 4100 carburetors were available in two primary bore sizes depending upon engine size application. You would find either a 1/8, 1 inch, pretty much a 1 inch bore, to a 1 and 1.12. Both automatic and manual choke versions of the 4100 were built. Although most manual choke listings for Autolite 4-barrels were basically limited to trucks and the 289K engines, and sizes varied between 475 to 600 CFM. And you would say, well, 475, believe me, that was really nice applications for small displacement engines, because drivability was a good thing because of the size of the Venturis didn't allow for manifold vacuum to drop under full throttle, because the vacuum is the carburetor's best friend so far as getting the thing to actually pull fuel out of the bowls. Now, automatic chokes were preheated by an aluminum tube, which brought heat from the exhaust manifold into the choke body by opening the choke spread bore more quickly. Old timers referred to the 4100 as the shoebox because of its shape and its simplicity and the configuration. Another feature of the Autolite 4100 series 4-barrels was that they were the first carburetor to incorporate an annular discharge booster Venturi way back in 1950s. And an annular discharge booster is a ring of multiple discharge holes located higher in the Venturis than your typical straight leg, down leg, single hole Venturi. This leads for better fuel atomization. And I'll give you a little bit of background of that real quick. The reason why engines run better whenever they're warmed up, that are carbureted anyways, is because fuel tends to stick to stuff. In other words, when you introduce it and mix it into the air, as soon as it hits something, it's trying to separate from that air and stick to the walls of wherever it hits. And if I don't know if you've ever studied fires in houses, you ever notice they can find the hottest point of the fire wherever there's no soot. They can say this was the hottest point, because what happens is it tends to repel whatever wants to stick to it. So, and by the way, fuel has a low evaporation temperature. So if the intake is warmed up, i.e. the engine warmed, then the fuel is not likely to separate from the air and stick to the walls of the intake and the bowl ports of your cylinder heads, which would cause a lean condition. So that's why that's why the engines that are carbureted run so much better at operating temperature. Of course, there is a fine line to that, because too much temperature can cause the air to be somewhat not as dense, which then gives you a rich condition because you don't have usable air to burn for the fuel that's there. So that's why you always want to balance that temperature. And by the way, because of heat in the intakes to keep the fuel from sticking to the walls, that's why you often see coolant lines running nearby or using coolant to pass through certain sections of the intake, because you need that to get the intake up hotter quicker, because it provides for better drivability. Just a little history on that. But anyways, the annular discharge design also creates more vacuum, which helps to draw fuel more efficiently from the annual discharge bowls. I'm adding a little bit to the article here, so in case. But anyways, discharge-equipped carburetors also can run smaller jets because they are more fuel efficient and at all range and performance carburetors used in NASCAR and other racing divisions. That was some of the innovations when they used NASCAR to actually build platforms off of great drivable vehicles. They used that was the thing until they completely annihilated the use of what was normally a stock car. But many styles of aftermarket carburetors have been adapted to annular discharge Venturis for racing applications. In fact, Holley paid for most of the use of the design for many years before eventually buying it from them. There you go. See the similarities in power valves and different things like that. By the way, the power valve is used under under low vacuum when you have a bellowing effect, or the fluctuation of vacuum in the intake manifold, which would create a situation to move that little diaphragm in your power valve and kind of pump the fuel to the annular boosters, because at low vacuum, at low CFM or low airflow by the jets, didn't provide good atomization, or didn't provide a good place for fuel to be pulled out of the bowl and atomized. So you'd pump it in there with that little power valve. And that tends to smooth out once RPMs increase and the signal of your intake, stabilizes. Put a vacuum gauge on something and throttle it and watch how the gauge fluctuates. Anyways, before eventually buying it from Ford when discontinued making carburetors and started fuel injection, although many were swapped years ago for the 4150 and 4160 Holleys, these two models were also featured right alongside the 4100 on many 1960-era engines as original equipment. Restorers and muscle car enthusiasts are now seeking out these original equipment units as complete and authentic Ford AMC restorations. They make great carburetors to build. You can mess with the jettings on them. They're so reliable. The easiest way to identify these carburetors, like I say, is the letter tag. So let's go back to the Me real quick. We'll talk a little bit. just to kind of clarify, let me show you a 4300 1977 model carburetor. I dug this thing out real quick. Check this out. Okay, right here, D7, 1977. Let's look at the bottom of this thing. As you can tell, they were really starting to put some emission stuff on this with the way they're trying. They didn't want, they wanted to minimize the vapor, vapor lock effect from whenever the heat soak goes into the carburetor. And notice a little bit of a similarity between it and the thermoquad, the way it kind of looks a little bit. Let's flip it over and see. By the way, that's a bowl vent that would normally go to a charcoal canister to reduce the validity of fuel fumes into the ozone, according to the EPA. And a lot more vacuum stuff too, you can see. Now, see the spread bore design? See how it's the smaller Venturis in the front and then the rear has a larger Venturi? They call that a spread bore because the size of the Venturis are different from the front to rear. The reason why they would do that is because under heavy load, full throttle situations at offline with low RPMs, without these opening up, that provides a great vacuum signal over your front Venturis. That's why a mechanical secondary carburetor is usually used in an application where it's lightweight vehicle, good gearing, or a stall converter, because the motor can spool up, allow for CFM to go by the Venturis to open them up. And it uses a nodular design, same thing as the Venturis on the 4100. And like I say, this is 12 years later, guys. Boy, we've come a long way in 12 years. And this little section right here was part of an idle circuit. That big old hole right there was used for part of an idle circuit. It's weird how they done that. But that's, and of course, electric choke now. We're working our way up, and it looks just like what off of a Quadrajet, except for it says Motorcraft on there. You know, they were like, guys, it works. Let me just change it a little bit. Don't nobody say anything. So that's a little bit of a history on some of the early 4-barrel carburetors from Ford that were innovative designs that companies picked up later and built off of, like Holley and all. Notice it's got a butterfly similar to a Quadrajet. This also, if this thing opens up fast enough, this thing here doesn't allow it to open all the way yet until there's more vacuum going to this. Signal over the annular boosters provides fuel atomization. That's the whole key to a carburetor working well. That's why, believe it or not, you're not going to like what I'm about to say, there is a superiority when it comes to fuel injection, because a lot of that doesn't apply, especially in a dry intake where you're not having fuel dumped into an intake that's cold. Chevrolet used a TBI setup, which worked great, but sometimes they were weird and wonky at cold starts, especially really cold temperatures, because you still have that fuel separation that happens under cold intakes where it's trying to get away from it, stick to the walls. I hope that helps. I hope you enjoy that video and have fun messing with really cool old carburetors. And if you have any questions, leave it in the comment sections. I do check all this stuff. I got dirt on my face. I do check all the comments, and I try to respond to try to help people. And we'll do a video after. We're going to build this carburetor, that 4100. We're going to put it on a truck that I have that's running a 460, i.e. that is a small Venturi, but this has got a highway gear. And the truck is, being it's a big block, doesn't rev a lot of ice. Design will keep it in an RPM range of around 5,000 RPMs, which means that the carburetor will be just big enough, which will provide the kind of low-end torque that I'm looking for with my highway gears. So you guys, please hit that like, subscribe, and share. Have a wonderful rest of the week, and I'm out.